All right, welcome to the non-contact forces electric field sim through the FET website. So you're here on the dock. So let's just jump right into this so that this video isn't too long. Use this at the beginning, watch through, and kind of go through the video and parts of the sim together. I think that's going to help. And then two, you can always come back to this video if you get stuck or you have questions about things that I'm answering in the video now. So go ahead, click on the link that's here. And once you click on the link, hit the little thumbnail that has like the play button on it, and then it should open in a new window, and it should look like this. And that's the sim. If you want to play around with it a little bit just to see what's going on, you can. But I would like you to, once you're done with that, let's go back and do the introduction, because the introduction is done before we actually do any of this. All right, so I am here at the introduction. Let's see. I don't know. There you go. So I'm here at the introduction. Okay. For hypothesis number one, okay, so these are questions. Every time we do an investigation, you are going through and you're trying to investigate the answer to the question. So the question that I posed to you for the first one is, how does the distance an object is away from an electrical charge affect the strength of the charge of that object? And so we answer these questions with predictions, and these predictions are called a hypothesis. And the correct format for hypothesis is the if-then statement. So I have modeled these for you. We would have done this together in class on the board or something, so I have them already typed in there. You just have to finish them. So let's look at the first one. So to answer that question, I'm going to say then, well, if I'm going to change the distance, let's pick either increase or decrease the different distance. So I'm going to pick increases. So it's going to say if the distance increases, okay, so meaning that I'm moving further away from the charge, then the strength of the charge on that object will, and your prediction would be that it's either going to increase or decrease or stay the same. Let's go ahead and type that in now. Same thing happens here for number two. I start and model it for you. And again, we're talking about what's going to happen to the strength of the charge. This time it's a different situation. You can read through that on your own, but you're typing in one of the three results, just like the first one, that can either increase, decrease, or stay the same. So go ahead and make your prediction and finish that. Okay, and then for hypothesis three, and if you need to pause, and then just come back. But for hypothesis three, it's how does the charge, whether it's positive or negative, affect the direction of the electrical field? So let's just pick, and let's just start with the one, and I'm just going to say if the charge is positive. So if we put a positive charge into the field, then the direction of the field will be, and your choices would be that it's either going to be away from the charge, moving away from the charge, or moving towards the charge. So it's either moving away or moving towards the charge. Okay? All right, so go ahead and type that in, what your prediction would be for your hypothesis for question three. So those are the three questions that we're going to go through and investigate today. And so let's go ahead and take a look at this, all right? Okay. Oh, I don't want this. There we go. All right, I'm sorry. I don't know why I did that. All right, so part one. Strength of the electric field and distance. Okay, so this is investigating the hypothesis one here, right? All right. Let's set this up, and then I'm going to kind of just give you a couple of pointers, and then go ahead and work on this section, all right? So here's for part one. All right, so it says, click electric field, voltage, values, and grid. So you have those things there. All right, down here at the bottom, you have charges. Okay, and so think of this as like a bucket of charges. So we have the red positive charges and the blue negative charges. The unit that you see by them, this lowercase n with a capital C, stands for nanocoulomb. And those are just representing really small charges, like really, really small. Um, so they're tiny. They're tiny charges. So don't worry too much about those for right now. But those are there, okay? And when you pull them onto the field and you release, you will see the voltage and the grid lines and the values show up here. And then a couple things that are really important to notice. Let me drag it back into the box there. This tool is super important for you. Okay, so again, it came from this box over here. This is the meter, okay? And this voltmeter is going to measure the voltage based off of the charge, okay? It's gonna, so you'll see values show up, numbers show up here for the voltmeter. So that's really important. Anytime in the document when I refer to meter, I'm talking about this thing here, the voltmeter. The tape measure you don't need, because since we click the grid, you can see here at the bottom what the representation is in terms of the scale for this grid. So you'll see the thicker grid lines here, okay? As I move from one thick grid line to another, each thick grid line, as I move across here, these vertical grid lines, the thick ones, each one is not a meter. Each one's a half a meter, because look, 1, 2. Every 2 are a meter. So this would be 0.5 meters. This would be 1 meter. This is 1.5, 2, and so on. All right. So those are important things to notice. You have your charges that you can drag out to the field. You know what the distances are between the major grid lines or the thick grid lines. And then you have your voltmeter over here that you can use to measure and get the measurement of the voltage based off of where you put this meter in the field here. All right, so that should allow you then to go ahead and move on to part 1. So go ahead and pause the video now and work on part 1, and when you're done, come back to part 2. All right, now that you're done with part 1 and you went through, you answered a couple of the questions that were here, and you should have this chart all filled out. Part 2 is even easier, and it'll be quicker. Okay, all you're going to do is now you're going through the second part of the second question that we're investigating from your hypothesis number 2 up there, and that's how the strength of the electrical field changes when you have a different amount of charge, because we only put one charge out there. And so when you read through the next one, it should be pretty easy to understand what it's asking you to do. All it's really asking you to do is to go through, and you're just going to put and keep placing new charges right on top of the first charge, and you'll have the meter out there so that you'll get the reading of it, and then just make sure that you're putting it in here in your chart as you go, and that should be pretty self-explanatory. So go ahead and pause the video here and go complete part 2, and once you're done with part 2, come back and we'll talk about part 3. All right, so now that you have this part done here, part 2 is done and this table should be filled out, we're now on to part 3. Part 3 is a little bit different. I didn't want to completely get rid of it, but it has to be different because we're not at school. So usually what I would have you do is to actually draw what you're seeing on your computer screen in terms of the arrows and what's happening with your arrows. I'm not going to be able to do that. If you still want to do it, you can, but there's nothing for you to show to me for this. But I still want you to do this so that you're at least making the observations and noticing what is happening. So it's going to have you do a couple of different situations, okay? And so that's what it says here. Skip the drawing part due to remote learning, but still set it up in the sim and notice what is happening for each situation. So you're going to start by putting 2 positive points 2 meters apart from each other, and notice the way that the field is. And when I say the field, that what I'm referring to would be, what are the arrows? Okay, so if I put one here, if I take another one, I put it 2 meters apart. So that would be 0.5, 1, 1.5, 2 meters. Okay, and so I'm looking at what's happening here with the arrows. And so I'm seeing with 2 positive charges, I'm seeing the charge move away from the force move away from the charge, and as they come closer to each other here, they kind of go up and out away from each other. Okay, and that's what I'm noticing for that one. Okay, for the next one, when I'm going to put 2 negative charges, 0.51, 1.52, right? 2 negative, I think, is what I said next, right? Yep. All right. So now you see here, kind of the same thing, except now the forces are pointing towards the charge. That's all, right? The field's all pointing towards the charge. But again, notice that the arrows eventually, especially when we look in between the two charges, that's the super important place to look. You have this open area right here, right? This open area. We'll talk about that when we talk more in the notes on Wednesday. Okay, and then place one positive and one negative 2 meters apart for the last one. So let's do that. 0.51, 1.52. Oh, and now I notice something way different, right? Of what's happening. Okay. That's all I'm really going to give you guys from that. All right, so that's kind of going through. If you want to go back through any of those now and just kind of look at them a little bit closer, you can. You can pause the video. There's nothing for you to do except just look at what's happening on the sim. There's nothing for you to do on the dock for part 3. As you move on to part 4. Part 4 is the analysis and conclusions. So there are questions on there. I think they're pretty self-explanatory. So I think you should be able to go through and answer these. I think as you get down to question 3 and 4, you'll notice that I stated for you guys here that this is this relates back to hypothesis number 1. This relates back to hypothesis number 2. So that I'm trying to show you that, yes, you went through and you actually answered the questions in the experiment. All right, the hardest part then is the graph. All right, it says insert 2 graphs using the data from part 1. One graph to show the relationship for the distance away from a positive charge versus the strength of the charge, and the other graph for the relationship for the distance away from a negative charge versus the strength of the charge. I don't need to see your Google Sheet. You can just copy and paste the graphs into this doc. All right? So, again, let me change it. I should say graphs. All right. So, you're going back to part 1, and you're using this data. And you're going to set that up in a Google Sheet. Okay, so you'll have the distance, and then you'll have your charges for the positive. 2 columns. Graph it, copy and paste it, put it in. Okay, make sure that you get a title. Make sure that you label the X and the Y axis. Make sure that you label any of the units, okay, so that we know what it is. So the distance, like for instance, on your graph, make sure you have an M next to it so you know that it's meters. Okay, copy and paste it in there. Then do the same exact thing. The first column in column A on Google Sheets, this third column with the negative charge and what you got, put that in for the for column B. Graph that, copy and paste it, insert it in down here at number 5. Those are the 2 graphs that you need to put in. Okay, that's it for this. Hopefully you can go through and figure this out as you go through. Good luck. Remember, I am on from 1 to 2 o'clock each day for Google Meet. The link is in Google Classroom to join me if you have questions, and we can walk through this some more together if you have specific things. All right, good luck. Remember, you're working on this over 2 days. So I think you would be in good shape if you finish this by the end of your workday on Tuesday, moving forward for the rest of the week. All right, thanks. See you. Good luck.